Good morning guys, Bob Murphy again. We're going to talk today a little bit about Henry's Law. And Henry's Law is all about gases dissolving into liquids. It's very, very important for us as scuba divers because when we go diving we are that liquid, and the gas in our breathing gas is what goes into our body potentially to form bubbles if we have a problem. So it's very, very important for us to understand a little bit about that gas going in and coming out. What I've done here is I've taken a large bucket, imaginary, I can see through it, and I've sealed it to my desk. This is the large bucket, upside down. Inside it I've put a glass with a fluid. I've drawn the same thing 3 times. What I'm going to do now is it's all sealed down. I'm going to introduce some pressure into this environment. So here's the first scenario here. There's the pressure. As you can see, there's a difference. So what we would say, if we were being very sciencey about it, is a gas gradient exists. You won't hear that too often, but maybe once or twice. There's a difference is what that means. Okay, what's going to happen here? The gas goes into solution. It goes into the liquid. Cool. Fantastic. We're not seeing anything here in the immediate. Now, if I move on to the next situation, situation number 2, I've done this and I've left it there for some time. And what's happened is the gas has dissolved in. It's inside. So, in this particular case, here we said there was a difference, the gas gradient. In this particular case, there is no gas gradient. And as divers, we don't really need to know that anything is happening here. As far as we are concerned at this stage, everything's finished happening. Okay, this state is also called equilibrium. That means that the pressures are the same, they've reached a balance. I'm sure you've heard that word before. We also call this situation saturation. In this particular scenario here, no more gas is going to go into that liquid because there is no more gas. If I were to change this pressure, then this would all change and these things would not be true anymore. But for the moment, that's fine. Now if I go to the third situation, I think it's fairly obvious what I'm going to do next. I'm going to remove the gas pressure. So suddenly there's a difference. It's the other way around. A gas gradient exists, and the gas comes out of solution. This state is called supersaturation. Big word, but all it means the pressure in the liquid is greater than the surrounding pressure. What's going to happen here is bubbles may form. Very important word there in the middle, may. Why does it only say may? Because let's look at you as a diver. Have you ever been here? I know you have. This is you. You are the fluid. Descended into your first dive of the day. Your body is empty, and suddenly you've increased the pressure on you, the fluid, in your lungs, The nitrogen starting to dissolve into your body. So you've been here. It's unlikely that you've been in this situation. However, you've been on your way there. And that was fine. And then at the end of the dive, you ascended. And the pressure in you, although it may not have been so high, you may not have been saturation diving, you may have only come up with a little bit of pressure in you. However, this is still true. The gas gradient still exists. The gas is going to come out. You are supersaturated, and hopefully bubbles in you have not formed or will not form, because that would be decompression sickness. It's very, very simple. Feel free to copy that down into your notebook. It might help you to actually understand in future.